So in the last session, we talked about usually error handling and caching, how caching works in the how in-memory processing of Spark works. All those things we explained in the previous session. In today's session, we'll be talking about an API called as mapPartition. Along with that, we will also see how to do secondary sorting. And we'll also see how to write how to write what is hash partition, what is how to write custom partitioner. These things we will see here. Map partition API, secondary sorting, how it is done, how hash partition works, and how to write a custom partitioner. Now let's take a API, how it looks like. We already know how a map higher order function looks like. Anand, I have already uploaded. That video is already there. Last Friday itself I uploaded. So as you can see here, yes, last session actually we talked about join, broadcast joins also, and caching. Actually, accumulators or error handling was done in the previous video. Yeah, let's see how the map partition API looks like. So to understand that, let's try to compare it with the map higher order function. So we have a collection of type A. On that we have a map higher order function. That map higher order function takes a function as a parameter, and that function takes an element which data type should be same as the collection data type, because this function will be called for each element of the collection, and the function that we pass, it will return some other data type. We transform the data, and finally we get some other collection. So here I'm just saying collection as a generic term. So here collection could be a list, it could be vector, it could be map, it could be RDD, anything. Because RDD is also a collection, we know that. So only thing is RDD is a distributed collection. And type, when I say A, it could be integer, it could be double, it could be string, a tuple, or anything, or a user defined class as well. So this is, we know that, a map higher order function which takes a collection and transforms into a different collection based on the logic that we are passing as a parameter to the map higher order function. In a similar fashion, we have a collection of type A. On that we have map partition higher order function. Map partition higher order function which takes a function again. Now this time it does not take an element, it takes a iterator of A and it returns an iterator of B. And finally it will return a collection of B. So this is the syntax of a map partition higher order function. As you can see here, both the function takes a collection and returns a collection. Both the function takes a collection and returns a collection, but the way it expects a parameter is slightly different. Here the function in the map higher order function, the function expects a single element. In map partition higher order function, the function that we pass as a parameter that expects an iterator of an element. That's the difference. Otherwise, the end result are same. Otherwise, the end results are same. But what is the logical difference here? What we can imply from this? We so the implication that we get here is called once per record. I mean to say it is called for every record. The better way to put it is called for every record. That function is called only once per partition. So that's the difference between map partition, map higher order function, and map partition higher order function. F is this function is called for every record, and F is called only once per partition. I mean, these are all the technical details. So internally, what it indirectly means what it indirectly means here is maintains the state at a record level. Here, here it maintains the state at the partition level. So what I'm trying to say here is when we use a map higher order function, and while it is processing, let's say, the third element, it doesn't know what it had processed in the first element. So it will not maintain the state. It will just blindly start processing the data. It takes the first record, process it. After processing the first record, it does not maintain the state of what it had done. Again, it the function is called for the second record. It processes the second record and everything is over. It does not maintain the state of the second record. So when it is processing the third record, it just processes the third record. It will not take into account what it did in the first two records. So that's what we can say about map higher order function. Maintains the state at the record level. Once the processing is done, it's gone. Here, since f is called only once per partition, it maintains the state at the partition level. So if I put it in diagrammatic fashion, So we have an RDD. Here we have record 1, record 2, 3, and 4. Here record 5, 6, 7, and 8. This is our record 9, 10, 11, and 12. So we know that this is one partition, this is one more partition, and this is one more partition. Partition 1, partition 2, partition 3. So that's our RDD. RDD is nothing but we have partition 1, partition 2, and partition. Our data is divided and available in different systems. Now when we call a map higher order function, we know that we are passing a function. To this function, first record 1 will be passed. Again record 2 will be passed. Then again record 3 will be passed. What I'm trying to say here is I have a map function and I have a passing a function. So this function will be called for record 1 first, then it will be called for record 2, record 3, and so on. Yeah, here is a question. The question is, can we increase or decrease the partition based on requirement? Yes, Naveen, we can increase or decrease the partitions based on the requirement. And similarly, we can say a function. Yes. Similarly here also, because this map higher order function will be called on each partition. Record 5, record 6, and so on. As you can see here, function is called for every record. It is every time it is called for a new record. So when it is processing the third record, it does not maintain what it has processed in the first record. So that's how the map higher order function works. And the way the map partition higher order function also takes a function. I will just say F1. Let's say different function it takes. Now the way F1 is called is, to this F1 you will be passing record 1, record 2, record 3, and record 4. This is what you will be passing to the function. As you can see here, this function now it is having the whole collection, whole partition as an iterator available. So it can loop through that. It can maintain the state at the partition level. Similarly here, the whole partition itself is passed as an iterator. Similarly here also, it takes parameter the whole partition itself as a iterator. Record 9, then record 11, and record 12. So it is called only once per partition. It is called only once per partition. And the whole partition itself is passed as a parameter so that it can maintain the state there. So I hope the difference between map function and map partition higher order function is clear. I I assume it is clear the way it is being called. Now what is the use case we need to see of map partition higher order function? Now this is all the technical details. These are all the technical details. When we use a map function, that function that we are passing is called for every record. When we use map partition, the function that we are passing as a parameter, that is called only once per partition, because the whole partition itself is passed as a parameter there. Now what is the use case of having map partition? So one is the performance, as you can see here. Instead of calling it for every record, you will be calling it only once per record. Obviously, performance wise, map partition is good, but otherwise also there are some other use cases that can be used, that can be solved using the map partition. To understand that use case, the use case is all related to maintaining the state. The use case is all about maintain. Since we are passing whole partition as a collection, we are passing whole partition as a collection to that function. Obviously, it will maintain the state at the partition level. Now this is the use case of map partition higher order function, and you will see an example. The example is nothing but the example that we want to see is sessionization. How to sessionize your data. This is where the one of the use case of map partition higher order comes into play. Now the question arises, what is sessionization? Any guess, anybody? What is sessionization here? Yeah, maintaining a kind of a session. Maintaining kind of a session here. Like if you see in Flipkart, they say there is those many sessions are created. Any e-commerce website, whenever you log in, there is your session. As and as you are browsing, your session is active. As soon as you log out, or due to no activity at all, your session has expired. So those things are sessions, and we have to make a sessionization here. So idea is this. Just let's say we take Flipkart here. You logged into Flipkart at, let's say you logged in at 10 a.m. Then you started clicking on the products. Some clicks were being done. You kept on browsing. Clicking means you are browsing the Flipkart website. Then what you did is you just came on. You started visiting some other website at 10. Some other website. Meaning there was no, and again you came back to Flipkart. So meaning there was no activity here. No activity for 5 minutes. So using this no activity time, so the Flipkart can decide whether it is session expiry or not session expiry, and whether it has to create a new session, or it belongs to the same session. Meaning, let's say the Flipkart has decided, Flipkart decided 20 minutes as session expiry. 20 minutes as session expiry. Meaning if there is no activity for 20 minutes, Flipkart will say that this session has expired for that user. So if the user comes back again, then that will be treated as a new session. That will be treated as a new session. So obviously here the user has came back within 5 minutes. So obviously this is just one session. Session one we will say. Again there are some activity here. Again the user is browsing here. Again at 10:20 a.m. went for a coffee break, we will say. So the user again, there was no activity, came back to Flipkart at 10:50 a.m. At 10:50 a.m. the user came back. So obviously no activity for 30 minutes. But and also we can see that Flipkart decided that if there is no activity for 20 minutes, so that will be the session expiry. So what I'm trying to say here, now Flipkart will say that up till here is session 1, and from here onwards it will be session 2. It will be a new session. So this is what we mean by sessionization. Otherwise, I mean, one is the logout. As soon as the user logs out, your session has expired. That is one sessionization. If the user does not is not active on the website for at least 20 minutes, then again we will say that the session has expired. We'll create a new session. The company, the Flipkart, will create a new session. Session ID 1, session ID 2. I hope the sessionization was clear. What do we mean by sessionization? I assume it is clear because I don't see any acknowledgement. I hope the sessionization is clear here. Now we want to achieve this. Okay. Now we want to achieve this using our Spark. We want to give some session name for each of the sessions. How do we achieve? Because whenever we browse on the website, there will be our dump, like which IP address we are from which IP address we are accessing the Flipkart website, the user ID, the timestamp. So we can use that timestamp. So every click you make, there will be a log dump which will have a timestamp. So it will have a user ID and it will have the IP address. So obviously, let's say user 1 is accessing from IP 1 user 1 at let's say 6 a.m. User 1 is accessing the Flipkart website at 6 a.m. He or she has done a click using uh, through his laptop, through his or her laptop, and the IP address of that laptop is IP1. Similarly, IP2, some user 2, some other user at 6, we will take it as seconds, 01 second, or we can write it in a complete. This is minutes, then you have seconds as 01 minutes. At second 02 second, there was one more impression from user 2 from some other laptop. I mean, multiple users, millions of users will be there. Continuously, will be getting lot of from IP3 user 3 at 6:03 one more click happened by user 3 in this fashion, and so on. The clicks are keep on happening in a similar fashion. Again, at IP1 user 1 at 6:04 IP3 user 3 05 IP4 user 4 06 IP2 user 2. So on the clicks are happening. So on the clicks are happening now. After that, again you have some more. IP1 user 2 IP1 user 1 at let's say 6:15 6:15 01 IP2 user 2 6:20 some seconds 05 IP3 user 3 something like this. Similarly I have IP1 user 1 at 10 o'clock 10:30 a.m. IP2 user 2 10:30 02 a.m. something. IP3 user 3 10:40 05 These are all the clicks, different clicks coming from different users at different times. So the Flipkart will be maintaining all these logs. Now the Flipkart has to do sessionization. Now to make the sessionization to happen, all the clicks from a particular user should be in one system. So let's say lot of dumps were there. The Flipkart collected whole 1 days of data, and then it will do the sessionization so that it can give a daily active sessions, how many on a daily basis, how many active users are there. Sessionization, some other use cases can also be done with sessions. So let's assume that for one full day, Flipkart has collected all these logs. Probably it will get some millions of logs, which may be in lot of GBs. Obviously, your data will be divided into blocks and stored across the HDFS file system. So let's just for understanding purpose, we have these logs. This is in block 1, this is in block 2, this is in block 3. Now, how do we achieve sessionization? The very first requirement is that all the records with the same user ID should be in one system, because we have to compare the time. So we have to compare this time with, again, oh, I have to see this as IP1, user1, IP1. This time has, we have to check the difference between these two times. This is the first click from that user, this is the second click from this user, and this is the third click from that user, and this is the fourth click from that user. User 1 have 4 clicks, let's assume that. We have to check the time difference between these two. What is the difference? If the time difference is 20 minutes, then we have to say that it will be a different session. So obviously, to check the time difference, then again the time difference between this record and the next record, the time difference between this record and the next record. So we have to compare the time difference, and it has to be done for each user, this record and this record, again that record and this record and this record and this record. Similarly, this record and the time difference between these two, this and again this and again this. So you have to compare the difference in the time, so that whether the difference is greater than 20 minutes or less than 20 minutes. Obviously, to do that difference, compute the difference, all these records has to come to a single system. Similar records, all the records with the same user ID. Here user ID will choose as the key. All records with same user ID must be there in single system, just like we did the item wise count. Internally, Spark has to will take care of bringing all the records with the same item ID to a single system. Here also, we have to make all the records with the same user ID should come to a single system. Now obviously, this record, this record, this record, and this record can come to a single system. Now, is that enough? Is that enough? Now, sometimes it may happen that this IP address is the home laptop. The user one has logged in from the home laptop and started browsing the Flipkart website. Now user one has gone, is in office. Here user one was in the home and the user one was using home laptop. So it will have its IP address, because the home will have its own service provider. Now office will have a different service provider, and in office the user is using office laptop. Obviously, the IP will be different. So let's say the IP is 5. So and the user also started IP 5. User 1 again some. at some time the user is started. IP5, here also the user started browsing. IP5, again it's the same user at 10:30 or 40 something. So this is user 1 who is in office. But from the home laptop the user did not from the home laptop the user did not log out. Somebody in the home is still, somebody else is using and started browsing. So that's the reason we are having this footprint, because somebody else from the home used the same laptop. It was already logged in through the user 1 and they continued browsing from there. Sorry. So that's the reason we are so what I'm trying to say here is this footprint is different and we have to choose this as a different footprint. This we have to choose as a different user, and this we have to choose as a different user, because somebody else is browsing with the same user ID at home, probably a spouse or a daughter or a son. Somebody else is browsing. Now in that case, choosing only user ID is not enough. All records with the same user ID must be there in single system, will not be enough. So we have to consider IP address as well. We have to consider IP address as well. And also the finally what should happen is the events should be sorted. Your records should be sorted. The records must be sorted by IP, user, and timestamp. I mean to say first your records must be sorted by user ID. It should be sorted by then IP address. It should be sorted then by the timestamp. So only if it is sorted, we can check the time difference. You cannot check the time difference between IP1, user1, 601, and next you cannot have IP1, user1, and 10:30 am. You should not check this difference. This record and this record should not be, the time difference should not be taken from these two. The time difference must be taken from this and this. Obviously the data has to be sorted. The data has to be sorted in that fashion. So so that's the reason we have to sort it by user ID, then the IP address and the timestamp. So I hope I'm able to convey the things of how these things are happening. So the idea here is, we know that if everybody from the Hadoop background know that sorting happens only on the key. Sorting is done only on the key. Sorting is not done on the value. Whenever there is a sorting done, we have APIs to sort. Sort is only done on the key here. Sorting is not done on the value part by default. Now let's say we'll take. So to understand this, let's we need to understand about the hash partitioning. I mean, lot of things are there interconnected just to showcase the use case. Now, what is hash partition? What is hash partition? To understand hash partition, so we'll go back to the our item wise count. So I said that all the records with the same key will come to one system. All the records with the same key will come to one system. Record 222, all the records with item ID 222 will come to one system. I said that Spark will take care of that. Once the data is in the form of a key value pair, Spark will take care. But what actually it does, how it takes care, how it brings all the records with the same key to single system, it actually uses hash partitioner. So internally some partitioner is being used. So that partitioner is called as hash partitioner. So what hash partitioner does is it computes hashing on it computes hash on the key, and it does percentage number of partitions. This is what the algorithm it uses to bring all the records with the same key to a single system. So here as I said earlier that reduce by key internally triggers shuffling, and the second parameter specifies how many partitions we want. So here we give the number of partitions. The same thing is used here. So Spark framework internally uses that partition. So let's say the number of partitions that we give is 4 there. Let's assume that. So what it will do is it will compute the hash on the key. Let's say the key is 222. Item ID 222, it will compute hash. Obviously, what will be the hash value? Some numerical value, a bigger number. It will have some numerical value. Just for simplicity purpose, I will say that numerical value is 12. On that, it will do percentage 4. So obviously, when we do the division by 4, the remainder will be 0. Meaning it will go to the 0th partition. All the events with the item ID 444 will go to 0th events, because every time we do a hash on item ID 222, we always get the hash value as 12. Percentage 4 will always go to the 0th partition. Similarly, let's say for item ID 333, the hash value got something 15. So when we do percentage 4, the remainder will be 3, meaning it will go to the third partition. So all the events, all the records with item ID 3 will go to third partition. In a similar fashion, let's say for item ID 444, we got the hash value as 23. Hash value as 23 again, and then we do partition 4. I mean to say, remainder, what is the remainder after dividing it by 4? Obviously we'll get as 3. Meaning all the records with event with key as 444 with item ID 444 will go to partition 3. So partition 3 will have all the records from item ID 333 and all the records from for item ID 444. In a similar fashion, we can have item ID 555 whose hash value can come to 40 something, because hashing is just a random value it will generate. So percentage 4 again, it will give the remainder as 0. So obviously all the records with item ID 555 will go to 0th partition. So this is how the hash partitioner works. So I hope you got the idea of hash partitioner. So whenever the reduce by key is being used, whenever the reduce by key is being used, internally actually internally it will go ahead and call the hash partition. Yeah, here is a question. The question is, but this will not distribute properly. So it depends on the how much key you have, how much records you have with 222. If your data is evenly, then the data will be evenly distributed. If you have lot of records with item ID 555, there is uneven distribution. That's true. There will be uneven distribution. It will not be a evenly distributed. Now, as you can see here, hash partitioner. So these two are the methods. So it is computing the modulo here. Modulo is nothing but a remainder, non-negative modulo on the hash of the key and the number of partitions. So this is the main method where you write the logic. If at all you want to write a custom partitioner, these two methods has to be implemented, because it extends from the partitioner, and partitioner is an abstract class. Partitioner is an abstract class, num partitions and get partitions. In the get partition method, we have to write our logic if at all we are writing our custom partitioner. So by default, hash partitioner is being used, which is already implemented, and it computes the modulo of the hash value. This is how it brings all the records with the same key to one system, because this get partition function is called by passing the key of each record. So that's how all the records with the same key will come to one system. So I hope the hash partition was clear here. I hope the hash partitioner was clear. Now we in our sessionization, we cannot use a hash partitioner. So let's see why we cannot use a hash partitioner in a sessionization. Now let's assume that only user ID is key. Let's assume user ID is the key. So obviously to bring all the records, our goal is to bring all the records from the same, all the clicks from the same user to one system. That is our goal. And once we have it, then we have to sort it by the IP address, the user ID, user ID, IP address, and the timestamp. It has to be sorted. Now let's assume that user ID is the key, and hash partitioner is and we are using hash partition, here. So what it will do? Obviously, on the user ID, hash will be done. It will get some value, and it will say percentage num partition. So we will get all the clicks from the same user ID in one system. Meaning you will get in this fashion: IP1 user 1 at 6 o'clock 01 second. IP1 user 1 6. What was the next event? 6:04 second. 6 o'clock 04 second. IP1 user 1 10. IP1 6:15:01. All this will come to a single system. 6:15:01. IP1 user 1 IP1 user 1 10:30. IP1 user 1 10:30 05 seconds something. So all this will come to a single system. Now here I have just put it as in a sorted fashion, but it may not be sorted. It may happen that it may happen that this record may come next. The data from system 3 has come first, and data from system 2 has come next. So here it will come, from here also it will come, from here also the data will come to a single system, which is nothing but this. Now it may happen that the data from third system has come first. 10:30 0:04 and IP1 user 1 6:15 has this record has came later 05 something. So obviously it is not sorted. Obviously we should not compare the time difference. You should not compare that 6 o'clock should not be compared with 10:30, because there was a event before that. So obviously we have to sort this. Each partition has to be sorted. But if you take user ID as key, but in our case user ID is key, so if you want to have it sorted, only user ID will be sorted. As I said, the sorting only happens on the key. Sorting only happens on the key here. So which is already sorted on the key. You can see that so you can get, after that you may get user 2. One second, let me put it in a much better fashion here. So we'll say that hash on user 1, hash on user 1 will give the value as uh, 12 something. So our partition is, there are only two partitions, let's assume as of now. So percentage 2 will give you 0. So all the records for user 1 will go to the 0th partition. In a similar fashion, let's say hash on user 4 gives you 20 as the hash value. So percentage 2 again it will give as 0. Meaning all the records with user ID 1 and user ID 4 will come to one partition, will be transferred to one partition. So what I'm trying to say here is IP1 user 1, IP1 user 1 at 6:01 AM. After that IP1 user 1 6:04, IP1 user 1 04 second. Then we have IP1 IP4 user 4 also will come to the same system, and it is 6:06, 6 o'clock 06 AM. Next again, let's say the record from system 3 came to the new partition first. So obviously IP1 user 1 10:30, IP1 user 1 10:30, 01 second I will say. Then you will have IP4, let's say this is IP4 user 4, IP4 user 4 10:40:05 AM, user 4 10:30 10:40:05 AM. Now as you can see here, this is how we bring all the records with the same user ID to one system. All the records from user ID 1, all the clicks from user ID 1 is available in one system. Then what happens is it will be sorted. When we say sort, it will be sorted on the key. Now key is our user ID. So once we have it, how it will look is, it will look IP1 after sorting. After sorting, it will have IP1 user 1 6 something, again IP1 user 1 IP1 user 1, again 6:04 6:01, again we'll have IP1 user 1 1030, IP1, 615 is also there, right? IP1, user 1, 615, 04 second. The record from the second system. The record from this system. This record I did not take into account. Now I am putting here. So once you sort it, then you will have IP1, user 1, 615. Then you will have IP4, user 4. IP4, user 4. So after sorting the data, you will get in this fashion because the sorting will be done on the user ID. Sorting is always done on the key. Sorting is always done on the key. So all the records with user ID 1 will come first. All the records with user ID 2, user ID 4 will come next. But now can we go and do the comparison of the time? So should we compare these two? So again, these two should not be compared because this click came later, this click came first. This click came first because its timestamp, if you see, it is 615. So it also has to be sorted on the timestamp. It has to be also sorted on the timestamp. It has to be also sorted on the IP address as well. But you cannot sort, but because your key is user ID. So you cannot do a sessionization on this data. So what we'll do is we will so since the sorting will happen on the key, we'll make key as user ID, IP, and timestamp because we want to sort it on that. We will make all the three fields as the key because we want to sort it on user ID, IP address, and the timestamp. If you only make key as user ID, one thing will be achieved. All the events with the same user will come to one partition, but it will not be sorted here as we require. So I will just put it here. If key is user ID, what will achieve? All records with same user will be in one partition. This we know that. If key is user ID, all records with the same user ID will be in one partition. But records will only be sorted by user ID. It will not be sorted by user ID, IP address, and timestamp because we want this. If you want to compare the time difference, you cannot compare the time difference between IP address 1 and IP address 4. You cannot compare the time difference between user ID 1 and user ID 2. Nor you compare the time difference between some timestamp and some other timestamp. So everything has to be sorted. It has to be sorted by user ID, IP address, and timestamp. But if you use the user ID as the key, you can only bring all the records with the same user ID to one system, one partition, but you cannot have the way it wants to be sorted. Here hash partitioner is being used. Here hash partitioner is being used. If key is now what will, since we want it to be sorted by user ID, IP address and timestamp, and we know that sorting will only happen on the key, so we'll choose key as user ID, IP address and timestamp. Our key is in this fashion. Now if we choose the key, as this, and if we apply hash partitioner on this, what will happen? If we choose key as this will not bring all records with same user to a single system, to one partition. So I hope you got the idea here. Because hashing will be done on user ID, it will be done in this fashion: hash on user ID 1, IP address 1, and 6:01. Hashing will be done on this whole thing. So obviously we'll get some hash value. Let's say the hash value is some 12. So when we do %2, it will go to 0th partition. User 1, IP 1, and 6:15 some 05 second. So lot of things has changed here. The time has changed. Obviously you will get a different hash value. Let's say the hash value is 13 something. So when we do %2, it will go to the first partition. So if we choose user ID, IP address and timestamp as the key, and if hash partitioner is applied, then you cannot bring all the records with the same user ID to a single system. Obviously you cannot do sessionization. The sessionization's requirement is these two. Sessionization requirement is what? Sessionization requirement is all clicks from from same user must be in one partition, and all clicks record must be sorted by user, IP, and timestamp. So this is the requirement for sessionization. Only if you have all these things, then only we can compare the time difference between the clicks. Otherwise you cannot compare the time difference between the clicks. So to achieve this, all clicks from same user must be in one partition, and all clicks records must be sorted by this. By choosing user ID as the key, we can bring all the records. The first requirement gets satisfied here, but the second requirement will not get satisfied because it will not be sorted. Now if I choose user ID, IP address and timestamp as the key, it will be sorted on user ID, IP address and the timestamp, but the first condition will not be satisfied. Now what has to be done here? Now what has to be done? So this is where we use a custom partitioner. What we'll do is what we'll do is we know that we have to sort it by user ID, IP address, and the timestamp. So in that case, what we'll do is we'll choose key as user ID, IP address, and the timestamp because we have to sort it on that. But we cannot use hash partitioner because hashing will be done on the complete key. So we'll write a custom partitioner. We'll write a custom partitioner. Custom partitioner will extract it will extract user ID from the key. It will extract user ID from the key, and hashing will be done on user ID. So this will make sure that all the records or all the clicks from the same user ID will come to a single partition. And since the key is user ID, IP address, and the timestamp, so we can make sure that we can sort it on user ID, IP address, and timestamp. So here what we are doing is we are taking key as this. We are taking key as a multiple fields, and we are writing custom partitioner, and sorting will be done. So if we choose multiple fields as the key, so that's where the sorting is called as secondary sorting. So we are achieving a secondary sorting because not only the sorting happens on the user ID, the sorting also happens on the IP address and the timestamp. And because of custom partition, we make sure that all the records with the same user ID will come to one partition, and all the records are sorted by user ID, IP address, and the timestamp because of the key. So once you have all these things in place, then you can compare the timestamp. Then you actually compare the timestamp. Compare in this case, if you write in that fashion, it will be in this fashion: IP1 user1 601, IP1 user1 604, IP1 user1, it will be 615 will come first because it will be sorting on the user ID, IP address, and then the timestamp. So obviously this record will come. Then it will have IP1 user1 1030. Then IP4 user4, and this IP4 user4, and this. I hope my voice is audible now. Yeah, there was a network disconnectivity. I have re-established here. So now we know that we because of choosing a different key and because of using custom partitioner, we got our data in this fashion. We don't want our data in this fashion. So now you can compare these clicks. What is the difference between first click and the second click? What is the difference between this click and the second click and the third click? What is the difference between the third click and the fourth click? As you can see here, the fourth click difference is more than 30 minutes. Obviously, this will treat as session 1. So this will be treated as session 2 for that user. So this will be treated as session 2. And to compare the time difference, obviously we have to maintain the state for each partition. So this, to compare the time difference, we will be using mapPartition higher order function. Because you cannot use a map higher order function because we have to check the previous record time while we are processing the current record. While we are processing the current record, we have to check the time of the previous. But map higher order function does not maintain the state at the partition level. You will not be knowing what it has done in the previous record while processing the current record. So that's where the map partition higher order function will come into picture. So I hope the use case of map partition higher order function is clear. Let's see an example of that. Whatever sessionization example I have said here, we have the code for that also. We'll finish that and wind up the session because I don't want to stop it in between. So for that, you have to open one more project called e-commerce marketing. Again, it is there in my virtual box. You have to open this. It is a complete end-to-end pipeline. From that, I'm trying to explain only the map partition. I'm trying to explain secondary sorting, map partition, custom partitioner, and sorting within the partition. So these things, this is the sessionization is part of this complete project. Sessionization is a part of this complete project. So if you go there, you will see that sessions, there is something called as mine sessions. I mean, some things you have to ignore it. Some things you have to ignore it. That we'll see later. As of now, just assume that we are having a RDD. Just assume that we are having a collection. Now this collection has the IP address, it has the user ID, it has the timestamp, which record has which item has been clicked, the timestamp, everything is there in the RDD. Just assume that we are having a RDD. Now there is a something called as key by. So this will transform your RDD into a key value pair. You can use a map higher order function also, but there is a method called key by which takes a function, and whatever this function returns, that will be made as the first element of the tuple, and the whole record will be made as the second element. Whole record will be made as second element. Key by will do that. So here our hit key is nothing but our key. So just this from function, what it does is it returns IP address, user ID, IP address and the timestamp. It returns this class object. User ID, IP address, and timestamp it returns. This function returns that. This function. So whatever the function returns, that will be made as the key. If we use key by, it will be using. I mean, this is the difference. Just to give a difference here, you have an RDD. You have an RDD. You have record 1, record 2, record 3, record 4, record 5, and so on. Now, usually how you transform it into a key value pair. So this record has IP address, user ID, timestamp, page, which page, a user agent, status. Lot of other stuffs are there. Each record has these fields. Now, how do we do a key value pair? We do a key value pair by saying a map transformation. Take each record and get return in this fashion. Key will be record dot IP comma record. This whole thing will be made as one key. You can define a case class, a key as user ID, IP address, and timestamp. Your class name is a key. Hit key will say, or click a key. I'm just trying to show the difference between key by and map. So I will define a class as hit key. So you take each record and you create a tuple. You take each record and create a tuple with hit key as the user, r dot user, r dot IP, and r dot timestamp as your first element of the tuple. Second element of the tuple will be the record itself. So once you do this, you will have a RDD. You will have a RDD with hit key 1, I will say record 1. Hit key 2, record 2. Hit key 3, record 3. Hit key 4, record 4, and so on. So you have to transform your data into a key value pair. Only then Spark will know that this whole three fields combined is the key. So either you do in this map higher order function, or what you can do is you can use key by method. Key by method is also doing the same thing. This function that we are passing, that function just returns this. This function returns this object. As a result, you will get the same thing. Either you use a map higher order function, or there is a by key itself which we can use it. Now, when we do a by key, let's say that the data will be in this fashion now. It will be transformed into a key value pair, where key is nothing but IP address, user ID, IP address, and the timestamp. Now we have to write a custom partitioner. Then we are saying repartition this by using a new partitioner. This is our custom partitioner, hit key partitioner. So as normal hash partitioner was returned, which extends partitioner. We saw the hash partitioner. In a similar fashion also, in a similar fashion, we have to write our custom partitioner, and we have to override these two methods. The number of partitions remains as it is. Now we should not hash on the key. Now our key is an instance of this. Get the key, from the key, use the user ID as for computing the hash. This is what I said here. Write a custom partitioner, extract the user ID from the key, and hashing will be done on user ID, which will make sure that all the clicks from the same user will come to one system. This is the modulo function. You can find it anywhere. But this is the main logic we have to write it. That's our custom partitioner. This will make sure that the hashing will not be done on the key. The hashing can be done only on the user. Yeah, here is a question. The question is, can we do the same custom partitioner in Python also? I think you can do it. Not sure on this. I haven't worked on Python, but it should be doable, I think. It should be. I'm not sure, because since this is a completely Java code, can we extend this with respect to Python? I'm not sure on that. Now, because of this and this repartition using custom partitioner, this will make sure that all the records with the same key will come to one system, and then you have and sort within the partition. This whole API is a repartition and sort within the partition. This will make sure that it will be sorted by the key, which is user ID, IP address. When we say sort, we know that sorting will only happen on the key. So the key here is user ID, IP address, and the timestamp. So this API, these three APIs, or these three code of line, is what I have explained the whole thing. Your custom partitioner, your secondary sorting, because there are multiple keys. Now once you have your data, now you have your data in this fashion. After doing this key, custom partitioner, and sorting within the partition, you have your data in this fashion. Obviously now you can start doing the comparison. This is where we will be using the map higher order function, map partition higher order function. So on that key value pair, you can hover and check on that. You can see that, just forget about the row here. Row you can think as a record, because row is actually the data frames comes into picture. We haven't discussed the data frame, but not to worry about. Just think of that this is a RDD of a key value pair. Key is that class object which has three fields, and the value is the complete record. So map partition higher order function is called. On that, this we are passing a function literal. We know that map partition higher order function is a higher order function which takes a function, and that function takes whole partition as a iterator. So the whole partition will come here. Sorry. There we go. So here for that whole partition, you will be sending the complete partition, which has all the whole partition of our user one IP1 timestamp, user one IP1 timestamp, user one user 4. The whole partition is sent as a parameter. The whole partition is sent as a parameter to this function. That's the meaning. So now you can maintain, you are maintaining the state at the partition level. So this is where we are getting the sessionization. So we go through, we are running our for loop. We are running the for loop. We go through that iterator, each element. We take the current record, which is a key value pair. Current record underscore one will be the key. That key is nothing but a hit key, which has three fields: user ID. We check the user ID. We check the IP address. We check the time difference here. First record and the previous record time difference. If that time difference, we have some time difference idle time here, we are setting it to 60 minutes. Sorry, 30 minutes. If the idle time between two clicks is 30 minutes, then we say it as a different session. Then we say it as a different session. So this comparison is possible. This comparison or comparing with the previous record is possible because of our map partition hierarchy function. So here first we need to compare first record. Now with which you will compare this record, because this is the starting point. Now the second record you will be comparing with the first record. So you have got a comparator for second record, but with which you will be comparing the first record, because there is no other record it has to be compared. So obviously we'll have some dummy record to be compared. So that dummy is nothing but previous hit. We are setting our dummy as our user ID is dummy and null. Our IP address is also null. Our timestamp is some 0. So we have our key with the dummy key we are saying. So our previous hit we are taking as a dummy key. Now the dummy key will be compared with the current first record. Obviously it will not match. Obviously user ID will not match. User ID will not match. We will create a new session ID for this. So our session ID will be stored as here. We'll create a new session ID. This is how, since this if condition fails, it will come to the else part, and in else part we are just generating a random ID and we'll consider that as a session ID. Our random ID is nothing but a session ID, and that we are storing in the session ID, and finally we are updating our previous hit. Our previous hit was this, and our session ID was also dummy. Now our previous hit is nothing but the current records key, and our session ID is nothing but the random ID generated. So what we have done is, so we have this record. instead of this I will. So what we are having is, first we need to create a session ID, right? So to create that session ID, we are having our hit key and our session ID. Initially, everything will be dummy. We have hit key here and user ID is dummy, IP address is dummy, timestamp is this, and the session ID is also dummy. As soon as we read the first record and compare it with this, our key, there will be some session ID 1 created. Session ID 1, some random number we are generating here. For hit key is for user 1, IP 1, and some timestamp 601 timestamp 604 615. For all these timestamp, 01 IP1 hit key 01, sorry, user 1 IP1. This session ID will remain the same. Next is our hit key. Current key is nothing but user 1, IP1, and 1030. So this is our current key. This is our previous one. So now we have to compare these two. IP address is same. User ID and user ID is also same. Now we'll see the time difference. Now we'll see everything will work same. User ID of the previous current hit and the previous hit is same. IP address of the previous and the current is also same. Current timestamp minus the previous timestamp, it is more than the max idle time. It is more than 30 minutes. Obviously, again we'll go to the next session. Sorry, I will go to the else part and a new random number will be generated. Let's assume that new random number is, we'll say as a session 2. So that's how we are. This is, all these clicks are one session. All these clicks from the user is another session, because the idle time was more than 30 minutes. So I hope all the concepts were clear here, whatever concepts I wanted to discuss. This piece of code, some other code is also there that we will see later, because to know that we have to understand the data frames. Just these things. We have RDD, we transform the RDD into a key value pair, because we have to shuffle the data and bring the records with the same user ID to a single system, single partition, and there are other criteria to bring that. You have to have your data sorted by user ID, IP address, and then the timestamp. So that's the reason we are writing our custom partitioner. And then we are using repartition and sort within the partition API. So this will bring all the records to all the clicks from the same user to a single partition, and it will be sorted by IP address, timestamp, user ID, IP address, and timestamp. Once you have that, then you have to compare the time difference. So that's where map partition higher order function comes, because here you will be maintaining the state across, maintaining the state at the partition level. So you can have while processing the current record, you are maintaining the state of the previous record. This you cannot achieve with the map partition higher map higher order function. And the logic, it depends on what logic you are giving. Since you want to get sessionization, so we are just checking whether the IP address is same, whether the user ID is same, and whether the time difference is lesser than 30 minutes or greater than 30 minutes. If it is lesser than 30 minutes, we say it is the same session. If it is greater than 30 minutes, we'll say it as a new session, and the new session ID is generated. We will run this program as when we see the complete end-to-end pipeline. So this is just a part of the end-to-end pipeline. So I hope all the things were clear here. Let's wind up the session here with all these things, and let's continue tomorrow. Thanks everybody, and have a nice day and good night.